you recall the formula for the volume of a cylinder, you'd be able to recall that it's pi r square h. And basically what happens is that we've already done a formula for the area to the curve. Here, we are trying to see if that area rotates through 360 degrees about the axis, then it will form a volume. So we are trying to figure out what would be that volume. And just like we did earlier on, considering the concept of calculus, if we consider a very, very small change in x, and we call that dx, and the function value to be y, so as that area rotates and it forms a very, very small circular disk volume, the volume would be pi r square h, and radius would be y, and height would be dx. So a small change in volume would be equal to pi y square dx. So, but if you want the volume for the entire solid, then you have to take the integral. Integral will add up all of these volumes. So when I integrate both sides of the equation, integral dv becomes the volume, and that becomes pi y square dx. So this is the formula for the volume of solid form when the area under the curve rotates 360 degrees about the axis. We said that a small change in volume is equal to pi y square dx. That's the volume of a small segment. And I want to add volumes of many such disks. So to add, we do integration. Integration is the summation of values. So the original equation, I integrated with the limits a to b, the range in which I want to find out the volume, and integral dv becomes b. And the right hand side becomes pi y square dx. So that gives you a formula for the volume of revolution, that if a curve area rotates about the x-axis, then the volume of solid form would be pi y square dx. Now this is a formula you have to remember, in which you just have to remember that you have to put a pi outside. This is y, the equation of the curve, and this is the limit for the volume, the lower limit for x and the upper limit for x. Okay, and then the last thing is that just like we talked about area between the curve and the x-axis rotating above the x-axis, you could also have a situation where the area between the curve and the y-axis rotates about the y-axis, and that can also form a volume of revolution. In that case, you just switch the variables. Just like you have pi y square dx, it's going to end up becoming pi x square dy. And the limits, of course, over here it's dx, so you have limits of x. If you have dy, you'd have limits of y. And that's how you will get the volume. So it's like if I'd say that, for example, I have an equation of the curve. This is y is equal to x square. And I would say that you have this particular area under the curve from 0 to 2. And this area rotates about the x-axis and generates a volume, a solid. And you have to find out the volume of that solid. So you recall a formula which is volume is equal to pi integral y squared dx, a to b. So if it's y square, and you already have this y square, and since you already have y as x square, so when you try and apply this formula, guys, how would the formula look like? Volume equals pi integral, the lower limit is 0, the upper limit is 2. In place of y, I'm going to write down x square, having a whole square over that. And this becomes pi 0 to 2 x to the power 4 dx. Pi x to the power 5 over 5 the limit 0 to 2. And this becomes pi by 5 into 2 to the power 5, that's 32. So guys, 32 pi by 5. You can also write this down in decimals unless the examiner asks you to find out the exact volume. This would be the volume formed when this curve, the area in the curve, rotates 360 degrees about the x-axis. The area between the curve and the y-axis is being rotated 360 degrees about the y-axis, and you have to find out the volume formed. So in that case, guys, what we're going to do is that our formula would change. Instead of pi y square, it will be pi x squared dy. So the limits are going to be the limits of y, which is still 0 over here, but if you put x as 2 in the function, it becomes 4. So the limits of y are going to be 0 to 4. It's pi integral 0 to 4. And then you have to replace x squared. X squared is directly y, so it becomes y dy. So the volume would be pi y squared upon 2. And the limit is 0 to 4. Right? And then it becomes pi upon 2, 4 squared. 16 upon 2, this is 8 pi unit cube. That's how you get the volume.